Hi, this is the video demonstration for LectsSearch version 2. In this video, I will showcase to you the various features of LectsSearch from the user point of view. This is the home page of LectsSearch. On this page, the collections we have in our offline database are shown as icons. We can either click on the image to navigate into a collection, or we can do a keyword search into all our databases. Take note that for thesis purposes, only the transcript of signal processing are ready at the moment. Hence, we will only be using lecture videos from signal processing in this demonstration. Let me begin by showing you the navigation into specific lecture videos without the use of search. On click on the icon in the home page, you will be redirected into the collection page. In the collection page, you can directly choose to watch a lecture video by clicking onto the respective image icon on the right. You will now load up the document viewing page. On this page, you can see the interaction between the HTML file player and the transcript. Once the video starts playing, you may skip to certain segment of the video by clicking on the sentences in the transcript tab, and vice versa. This is done via JavaScript and CSS.
The following content is provided under a Creative Commons license. Your support will help
In the last lecture, I introduced and illustrated the kinds of signals and systems that... Let's begin with one signal, the continuous time sinus. The parameter A is referred to as the amplitude, or said another way, if we... What I mean by periodic, now the sinusoidal signal and graphically, now the sinusoidal signal.
With navigation aside, we can now go to the main part of the system, the various search functionalities. As you can see on the right-hand side of the search bar, we have an audio button. This is a newly added feature, which is not written in the report. This audio recognizer can take in mic input and do a search for you. Let me demonstrate. Without saying the word search, the audio recognizer will just append the words you have said into the input box. You may then click on the search button yourself. However, if you state the word search, it will automatically do a keyword search for you. Let me test it out for you. I'll click on the audio button and enable the mic. Testing. You see that the word testing is now appended onto the search bar. Let's say now I do a command search. I click on the audio button, enable the mic, search transform. You see the word transform now is now appended onto the search bar, and without clicking on the search button, a keyword search on transform will be conducted. Another command that I've added is the go command for navigation. Let's say we do go signal processing, and without any other mouse click, the page will move into the signal processing collection by itself. The audio recognizer is added functionality for usability. Of course, we can do a search manually by entering into the search bar as well. At the home page, if we don't make any selection, we will search the entire database when we enter a query. Let's try entering Lakota. As you can see, the autocomplete function is now at work. It will suggest to you the keywords that occurred the most in the collections. This autocomplete functionality allows users to do a content-based search. Furthermore, it is also dynamic. Let's say we go into signal processing collections. Because Lakota is not the top keyword found in signal processing, it will not be suggested at all. This is the same if you go into a document page. The suggestions list will update automatically at the back end according to which page you are at. I'll now prove to you that the keyword Lakota is not found in signal processing database. I will do a search into all database. As you can see, only one result is returned, and it's from Tech Talk. Let's try searching for a keyword that can be found in multiple collections. Let's try searching design. There are 9 results returned, and 3 of them are from Tech Talks. The rest is from signal processing. If we now go into a specific collection to do a search, it will only return results from signal processing. As you can see, only 6 results are returned. This keyword search functionality works by using the search using JAL file provided by the student in charge of component C3. The application will receive the results as a multi-dimensional array for display as search results. In this collection page, you can also see that we have a concept tree on the left-hand side. This is a specialized tree generated for every single collection. It can be expanded or collapsed. The taxonomy of this tree is created by the student in charge of component C1 using an ontology analyzer. The XML output will then be used by a jQuery JXML tree API to create this tree view. However, the API only provides a very basic HTML view. We want to allow the users to click on the node to do a concept search. This is done on the application side using JavaScript function called append to search bar. On the click of a node, the concept code will be appended onto the input bar, and the list of video with the selected concept will be returned. Furthermore, you may have noticed the number on the side of the node corresponds to the number of search results. This is also a dynamic feature. For instance, if the user is on the collection page, the number of occurrences of the concept is specific to the particular domain. If the user is on the document page, only concepts found in the document will be shown. This behavior is similar to the behavior of the autocomplete function. In addition, do note that clicking on more than one concept will do an AND search instead of an OR search for keyword search. Let me show you how the numbers will change. For now, if I click on signals, there are 14 results. That means there's 14 videos grouped under the concept of signals. If I choose a video with 8 concepts in it, you can see that in this video, there's 8 occurrences of the concept signals found for this video. This is another enhanced feature not from the basic tree provided by the API and is added to increase usability. User will now know not to click on the node if they see that the total count is 0. Lastly, I would like to showcase the unique search functionality in the document viewing page. Instead of a normal keyword search, the search bar is now used for highlighting search without a page refresh. This is a very important feature as we do not want to disrupt the playing video and it cannot be done by normal form search. Hence, with the use of AJAX, jQuery, JavaScript, and PHP, I've enabled the special AJAX highlighting search. Let's say we search for the word time signal in this page. It may not be viewable on the screen, but the player has highlighted the occurrences of the word time signal in the track bar. Similarly, the transcript will also highlight the corresponding occurrence in gray. If we click on the highlighted transcript, the player will skip to the exact play time. If we click on the next segment, it will go to the next highlighted segment. This functionality will also work on clicking the concept tree. The page will not be refreshed.
And depending on whether we're talking about continuous time or discrete time, so in the continuous time case, I indicate here an input x of t and an output y of t. If we were talking about a discrete, well, as a brief glimpse at some of the kinds of things that systems can do, let me illustrate first in a one-dimensional continuous time context, and then later with a discrete time example. One example of some processing of signals with an appropriate system. The particular example that I want to illustrate relates to the restoration of old recordings. And in the context of the frequency domain representation, some of the kinds of ideas and topics that we'll be exploring are the Fourier transform. The Fourier transform discussion we'll get into fairly early in the course, and the Laplace transform and Z transform represent extensions.
This brings us to the end of the video demonstration of the main features in LectsSearch version 2 web application.